Okay, so here comes the first thing, okay? What is it you're trying to find out? Well, you're trying to find out what's the model, right, for this. Okay, so the number of incidents, okay, is n, right? All right, so where, look at the equation up here. Where are you going to put the n? N's going to go in for 1. Okay, all right, for y is right. N will go in for y, is correct. N goes in for the y. That's the number it's going to be. Okay, equals, okay. All right, now A is the initial amount. What's the initial amount? 2573, right? Okay, so we put in 2573 there for A. In parentheses, 1 plus 0.92. 1 plus 0.92, beautiful. Okay, like that. And then to what power? To the t power. To the t power, that's right. There you go. Okay, now that is the exponential growth model. That's the model, right? In other words, the equation. Okay, that's the equation, right? Okay, very good so far. Okay, now Nick, you have questions?
The TX model will always stay like that?
Well, it depends what you're talking about, but yes, but no one's going to stay like that. Okay, now look, there's a second way to write this also, because you can combine 1 and 0.92 together. So if you also wrote the answer like this, okay, it would also be okay, right? And once again, it doesn't matter if you write the first one or the second one, I'd go like, okay, you understand this, you know what's going on. They're pretty good so far, but that's what we're doing. Okay, now are you done with the problem? No, you're not, okay, because there are 2 questions you're answering. There's the first part, the model. Now the second one says this, about how many incidents were there in 2003? All right, how many years have gone by at 2003? 7 years. So what are you going to do? You're going to put 7 in for t. 7 in for t. So here we go. We're putting 7 in for t, right? All right, now what you're going to do is go put that in the calculator. Okay. 2573 times 1.92 to the caret 7 power. Press enter, and then you tell me how many incidents do you get. Okay, all right, now you can't have part of an incidence, right? So you're going to round up, right? Okay, so you're like on what? 247. 485. You got it. There you go. And you've done the first problem. Look at there. There's this, right? Okay, now this is pretty simple. The x-axis is going to represent what? Time, right. See, that's easy. We are always x is time, right? So the x is going to be time, right? We're going to put time there. All right, now here's the next thing. How many years are you talking about right now? 7. Okay, so then you're going to decide each square is going to represent what? Okay, all right, now, okay, so that's up to you. Which one now? For this one, here's what first square decided. Let's make each square worth 1. But some people want it to be half a year. So then you would go every 2 squares and make it 1, right? And that's up to you. You decide the scale and put it in there, right? Your choice, right? But for the example you're going to see here, I'm going to make every square worth 1 on this first one. Okay, now let me ask you this. What's the y-axis represent? The number of incidents. So you write down number of incidents, right? Is what you're right there, right? Okay, so here I'm going to put down 0, 1, 2, 3, 4, 5, 6, 7, like that, right? And once again, if you want to use 2 squares, you can do that. Your decision. On the next example, I'm going to use 2 instead of 1. You'll see both of them, right? Then it takes us how you want to do this. Okay, now this is the tough part now I'm going to talk about. This is the part that gets a little challenging. This is everybody good so far with the graph? Okay, now we got to get to the second part of this, which is the y-axis and scaling the graph. Okay, let me ask you something here. At 7 years, how many incidents were there? 247,485, right? Everybody good? Okay. So you're saying to me that in year 7 I'd be way ahead, well, someplace here, right? Okay. So here comes the thing. Let's use that, and let's count how many squares are there going up the y-axis. So go count how many squares you see going up the y-axis. Okay, so all right, so some are going to see 14 and some are going to see 15, right? It depends if you stop at the line or go to the last one, right? Okay, so you can do 14 or 15. All right, do this if you would, please, now. Take 247,485 and divide by either 14 if you want to, if that's what you get it, or 15 if you want to, if that's what you get it. And tell me what you get. Okay, all right, so now, all right, so look over here. Did you get 16499 or did you get 17678? Is everybody getting that? Okay, right. Okay, so that's telling you each square is worth that much, right? Now look, that's kind of silly to use that number. That's a hard number to mess with, right? Okay, so now think about a really nice number to use. Well, 70,000 is nice, but there's something even nicer. Something even nicer.
20,000?
20 would be great. Round it up, make it into something really flat and nice. 20,000, right? And that's what you're going to see here. Okay, we're going to start, make each square worth 20,000, like that. Okay, so you see that declare a graph, and once again, you don't want to make it a goofy, squirrely number, right? You want to make it something very nice and neat. 20,000 will work. Okay? All right, now here goes the thing. So are you going to go up the graph and go 20,000, 40,000, 60,000, 80,000, 100,000, like that? No, not no. Okay, what would be in the good, let's say, let's put one at 20,000, declaring that's my scale, and now let me go up how many before I put another number? What would be in the good smart one to do? How many squares go up? 5 is right. You go up 5. 20 times 5 is how much? 100,000. So go up 5 and put 100,000. That's perfect. That's what you would do. Go up another 5 and put down 200,000. Right. That's right. You got it now. Go up another 5 and put down 200,000. And you could even go up another 3 and put down 2,000, so 260,000, right, if you wanted to. Okay, so everybody good? So you kind of scaled your graph now. You got a nice scale there. Okay, what's the next thing you think you're going to do now? No. Well, yes. But what's the next thing you got to do? No, something you do now. Put the equation in the calculator. Right, now you're going to put the equation in the calculator. All right, so here we go. The 2 of them. All right, you should get something about like this, is what you should be getting, right? All right, everybody get it? Once again, it has a little bit of jaggedy because once again, the smart board wasn't quite calibrated yet until the IT came and she helped me do all this. We got it all working. Okay, so all good, everybody understand so far? Okay, so now, so we're done with the problem, yes or no? No, you're not. Okay, you're not done with the problem yet, right? Because what else does it ask? Okay, all right. So it's saying to you, okay, use the graph to estimate the years where there were about 125,000. Now the thing is this, you don't have to use the graph, you can also go to the table. So you go to the table and look at the y values and see where is a y value close to 125,000. All right, it's at 6, so you think the answer is about what? 6 years. The answer is about 6 years, okay? Okay, and there you go, it's about 6 years. That's exactly right, you did it. Oh, okay. Yeah, which would be 2002, right? Okay. Which would be 2002. Okay, so all good so far? Okay, now, here comes the next thing. Okay, we wanted an exponential decay model, right? Okay, so it's going to be what? Y equals 4,200, right? Parentheses 1 minus 0.1 or 0.10, I put it up there, to the what power? To the t power, right? You got it. See, look at that, easy as can be. Okay, what's up?
Since they just did the last one, did you combine those?
Right, and I was gonna write that next, exactly, and you can combine them. So the other way you could write this is this. Y equals 4,200, right? And then 0.9 to the t power, right? 0.9, okay, they both are good answers in here. Okay? All right, now is that all you have to do on this problem? No, it says estimate the value after 3 years, okay? So now you're gonna put what? 3 in for t, okay? So you're gonna see me do this. It goes 3 for t, okay? Okay, now you tell me how much you're gonna get. How much it's gonna be worth. We'll do that on your calculator. Tell me what you're gonna get. Okay. Say again? Okay, all right, so if you're write down 3,000. 3,000. Be smart now. Are you right? It's money. 3,000. 3,061.80, not 80 cents, 80 cents. Okay. It's gonna be $3,061 at 0.80, 80 cents, right? It's not 0.8, because 0.8, you never see anything like that. Okay, it's gotta have, it has to have 2 decimals, or it has to have 2 places after the decimal. Okay, so everybody good there. Okay, so $3,061.80, okay? Okay, all right, now we're gonna graph this, right? Okay, so what's the x-axis gonna be? Okay, you know, it's gonna be, you're gonna label it, it's gonna be time or years, right? You put down time or years there. Okay, and what's the y-axis gonna be? Yeah, value or dollars, you can put something like that up there. I put dollars on this one, why don't you put value? Value is snowmobile, you put down all sorts of things. Okay, all right, now, okay, what's the question?
Like, with this one from yesterday, for the R, if it's less than 1, if it's going down.
That's right, so that's exactly right, so that's what you're learning, this is less than 1, so this thing's gonna be going down like this, right? You got it, that's exactly what's happening. Okay, it's decreasing in value. All right, so let me ask you this now. There's only 3 years you want to put down, right? Okay, so that each square is gonna be worth how much? Okay, all right, so, and that's up to you guys to decide, okay, but here on this one, what I told you already is this. We're gonna make each square worth half a year. So every 2 squares, we mean into 1 year, okay? And once again, just to show you different variations of this, you guys just gotta tell me what you wanna make it. So I'm gonna make each 2 squares with a 1 year, okay? So I put down 0, then skip 1, then skip 2, then skip 3, then skip 4, right? For my time. Okay, now we're gonna go to the y value. This is the hard part. So what number are you gonna put in the calculator?
Get that and divide it by
Yeah, but get what now? What did you get?
the $3,000.
No. Don't get that one. Which one are you gonna use? Yeah, the beginning price, 4,200. So put 4,200 in the calculator and divide it by 14 or 15, depending on which one you want to use. Okay? And then round it to a nice number, and what are you going to say? Each square is worth about how much? 300. You got it. It's worth 300. Beautiful. You guys understand how to do this now. Okay? Now, how many squares would you use before you put your next value? How many would you use? Personal choice. Nobody's saying anything. They're all freezing. How much you use? Yeah, that's what I use. I use 5. So I use 5. So 300 times 5 is 1,500, right? Is what I decided to do. So I did every 5 squares, right? Okay. Well, what's the next thing you do? Put it in the calculator and then go graph it, right? Let's do it. Okay. Okay, no, for 0 it's 4,200 is what that is. It kind of cramps together. Okay, it's 4,200. No, it's not, it's a 4. Okay, we got it. That's it, we got the lesson. Beautiful. Yeah, I know that. But like I said, but tomorrow's lesson is super quick. It does not take long, it's like, that's it, yeah, that's